From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
Capabilities that the process enables, such as fabricating complex geometries in remote location on demand. I guess I started showing some of the ugliness of it, correct? Hey, look at the fatigue behavior, look at the surface roughness effect, look into what volumetric defects can do to the structural integrity of your part. In fact, if you look into some of my early publications, they were highlighting some of those challenges.
That was Nima Shamsaei. Nima is currently the Philpott-WestPoint Stevens Distinguished Professor in the Department of Mechanical Engineering at Auburn University, where he is also the founding director of the National Center for Additive Manufacturing Excellence, a NASA and NIST funded research center focused on additive manufacturing technology. The NCAME is also one of the two U.S.-based founding partners of the ASTM International Additive Manufacturing Center of Excellence. Prior to joining academia, Nima spent many years in industry, including leadership positions specializing in fatigue analysis and durability test development. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. And we can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials, qualification, or general additive manufacturing support, reach out to the team through our website or via email at info@3degreescompany.com. All right, Nima, thank you so much for
joining. I have two options, got it or leave meeting. Which one I should take?
What's that?
I have two options, got it or leave meeting. Which one I should take?
I think got it.
Okay.
So, perfect. All right, Nima, thank you so much for joining the show today. Excited for the conversation. You guys have a ton of stuff going down on the manufacturing additive side and Auburn, which we'll touch on. But like I start with all my guests, would love to get some context of you as a person, kind of what got you motivated early on in your career and in your life. So maybe as part of your introduction, let's start really from the beginning. Where did you grow up? What were some of those early years like in kind of your education path that put you on the track to where you are today?
Sure. First of all, thanks for the invitation. Well, how far back you want me to go? I obtained both my bachelor and master's degrees in Iran, both in mechanical engineering. And right after bachelor, while I was doing my master, I started working for one of the two major automakers there. And a few years into my career, I was promoted to manager. And I was leading a group on design of vehicle components. It was very fulfilling. You can imagine you're 20-some-year-old, you have a team, they're reporting to you, you're a manager, but there was always something lacking. I always wanted to finish my PhD, correct? Get my PhD, be a specialist in certain field, and that motivated me to pursue a PhD program in the United States. So I looked, and my interest was more on fatigue and fracture mechanics. So I found a very renowned professor in the University of Toledo, Professor Ali Fatemi. I approached him, and he gave me an RA position. So I moved to the United States in 2006. After almost 7 years working in industry. So being a manager, having a nice residence, car, good living style. Now I'm back to the cold Toledo in January of 2006, no car, having a backpack, walking from my apartment to the lab and working 14 hours a day. So I survived for a few years. 2010, I finished my PhD there, but a few months before it, I received an offer from Chrysler, and I started working for Chrysler as the lead durability engineer. I was responsible for harmonization and correlation of different proving grounds that Chrysler and Fiat had around the globe. again, that was a great job. Imagine you have different platforms, you have different surfaces, and you want to have the same damage on hundreds of components, correct? It's a lot of interesting topic involved: damage calculation, optimization, adjusting the speed and number of tracks. And you want to make sure all these components, they experience the same damage regardless of basically the location you're testing them. So that was great. I worked there for 3.5 years. And again, something was telling me, wow, that's a great job, but do you want to do this for the rest of your life, or you want to be challenged more and maybe get into more research? That was one motivation to think about joining academia as faculty. The second motivation was when I joined at Chrysler. It was right after bankruptcy, correct? So, which was a great observation that I had there, because when I arrived there, 2/3 of the big building in Auburn Hills was basically Chrysler Technology Center, was almost shut down. And a year later, they were kind of running out of space. So they bounced back amazingly during the couple of years after basically the hard time they had in 2008, 2009. But the second motivation was I was one engineer in that group, and they saw a lot of good return of the investment in that area. So they tasked me to recruit several engineers with the same background. And we put the job out and we started interviewing. What I realized was it was quite difficult to find engineers with appropriate training in fatigue and fracture mechanics. And the reason being, universities, the main thing is to bring funding, correct? And you need to always basically follow money to survive. And at the time, maybe fatigue and fracture mechanics were considered as classical topics. So not many universities were offering basically those courses or specific research in those areas. So what we did, we recruited some good engineers and we just trained them. During the first month or two, they started at Chrysler. But that was my second motivation, correct? First, to go do research, so more challenge. Second, to teach fatigue.
And what was the kind of early on? Did you always think you were going to do kind of engineering? Kind of the fracture stuff came when you were doing your PhD, but like, what were like? Did you always like have that inclination to kind of the mechanics and engineering and manufacturing?
Yes. So back in Iran, when you finish, you start your high school, typically you go to two different areas, either biology, that they end up in, let's say, medical schools or pharmacy schools or dental schools, or math and physics that you end up in engineering. So when I went to start my high school, I remember they look at my transcripts and said, wow, you're very good in math and physics, so you're going to that track. And I said, okay, so that's the way I ended up in maybe engineering. Mechanical engineering, yes, among all engineering, I had the most passion for mechanical engineering. And why I ended up in fatigue, during my master program at Sharif University of Technology, we had a list of topics that we should have, basically we had to choose from. So I remember when I was looking at them, happened that my father was sitting next to me, and he said what I was doing. I said, I'm trying to pick a good topic for my master thesis. And he said, oh, what are those topics? And I said, these, and fatigue, blah, blah, blah. He said, oh, fatigue is very important. He used to be a pilot, and he said fatigue is very important when it comes to aviation. So that was maybe the motivation that I started my master's studies in fatigue, and then PhD, of course, in this area. And that, again, was a little interesting, because my strength was mostly in math-related topics such as dynamics and vibration, but I ended up in more like material side of basically mechanical engineering, which may not be as mathematics heavy, although it's very important, but not maybe to the extent of dynamics and vibration and control.
Yeah.
Yeah.
So I kind of interrupted you as you were talking about your career and at Chrysler and what you were doing there as you were bringing people on board for training. Was there ever a thought, like, at that time, I mean, you had kind of been in the university setting, you'd done your PhD, went back to industry. Were you still engaged with universities through any research or collaborations while you were in industry, or did that start later on?
Not really. Not really. I always wanted to, but I guess it wasn't that easy to manage.
Yeah. Yeah.
But I remember my advisor always told me that you should go to academia. You're good for that job. I didn't listen immediately. Maybe I was tired of graduate school and working long days and writing papers. But a couple of years into industry, I realized I'm missing something. Correct, at 5 with closing, going home, I don't have anything to do. So I guess that motivated me to take up one more challenge. So 2013, I joined Mississippi State University as a tenure track assistant professor, and now I have this background in fatigue and fracture. As I said, fatigue and fracture kind of considered kind of classical topics, not maybe many funding opportunities in that area. So I'm looking for where I can establish myself. And I've heard about additive manufacturing is becoming a very important topic, something that United States considering as a strategic area. And I started looking into the process material, and I said, wow, this is full of porosity and surface roughness. That's perfect for having fatigue problems. So maybe that's where I should establish myself. And it worked very well.
Yeah. Where did you first see additive manufacturing?
At Mississippi State, there was a very old lens system. In fact, the serial number, if I'm not mistaken, was 002. And it was funny because the panel back of it was gone, and there were all these wires connected, like ports to the other ports. I didn't know what they were. And luckily, the machine was working, and we could immediately do some research. And it started from there on DD systems. Then I moved to Auburn and focused more on powder bed fusion. But now we are kind of, for the last 3 years, we again looking into both a lot of activities on DD, powder bed fusion, and even binder jetting. But my focus again is on structural integrity, fatigue and fracture, understanding how process, post-process influence material and how material affects mechanical properties to be a specific fatigue behavior.
And so it's always the chicken or the egg question when it comes to kind of material properties and adoption and manufacturing. So when you were early on at Mississippi State, like you saw this technology, you heard kind of rumblings that, hey, this is a strategic technology and defense industry overall. Like, did you see it? Like, did you see like, hey, like I get where this is going. Like, even though it's kind of crummy right now, and like if you look at this part the wrong way, it's gonna just disintegrate. Like, were you kind of like, did you see some of the opportunities that certainly coming from industry that this could be applied to?
Absolutely. And while I guess many people were showing the opportunities in additive and the capabilities that the process enables, such as fabricating complex geometries in remote location on demand, I guess I started showing some of the ugliness of it, correct? Hey, look at the fatigue behavior, look at the surface roughness effect, look into what volumetric defects can do to the structural integrity of your part. In fact, if you look into some of my early publications, they were highlighting some of those challenges. So basically educating the community, hey, you need to watch for these challenges because they come and you need to address them. And that's why still I believe fabricating fatigue resistant, additively manufactured products still is quite challenging.
And for those who may not be materials engineers that are listening to kind of the show, like what, maybe get like a high level kind of overview of like why are some of additive manufactured parts not great at fatigue, or what were some of the challenges that people are trying to address in the technology today?
Sure. I mean, the fatigue failure, basically, you need to look into the mechanism causing it, correct? In the raw materials or more conventional fabricated materials, typically there are grain structures that they dominate the performance of the material. In additive, due to the high solidification we have, and depending on the energy input, geometry, feedstock, there are some other basically materials anomalies such as volumetric defects, gas entrappers, lack of fusion, keyholes, or rough surfaces as a result of layer by layer fabrication method, or partial or attachment of partially melted powder to the surface. So they can negatively affect fatigue behavior because they increase the stress concentration on their loading. Now, there are, of course, a lot of remedies that have been suggested, such as adjusting process parameters in a way that we can avoid more critical volumetric defects, such as lack of fusion or keyholes, or doing post-processing, such as hot isostatic pressing to close some of the pores, or surface treatment to remove the surface roughness. So these are some of the solutions being offered so far.
And so, I mean, Auburn has grown a ton in additive. So maybe do you want to just go like what's a day in the life for you look like? I mean, what are you doing in terms of your time between teaching and research, and you have ASTM, a Center of Excellence, like all these things kind of coming together. What's a typical day like in the 2 hours of sleep you get?
So somebody was telling me recently, how do you manage these? I said, do you think I'm managing? Well, maybe I give you first a little bit background how additive program was established at Auburn. So the first major move at Auburn was in 2015 through partnership with NIST to create a center called Center for Industrialized Additive Manufacturing. So the center was focused on metrology and NDE for additive. So it was a relatively slow start until 2017 that NASA recognized Auburn as their strategic academic partner in additive manufacturing. And that, of course, goes back to the long history Auburn has with NASA. And of course, I was part of a strategic hiring in 2016, correct, to take the program to the next level. So 2017, now we have our second major correct move. So now, and the recognition given to us, National Center for Additive Manufacturing Excellence, was from NASA through that cooperative agreement we signed with them. Now, right about that time, the call for ASTM came for the Center of Excellence, and we applied alongside with NASA. And what I've heard, there were 65 applicants.
Wow.
Yeah, and we were selected as one of the 2 US-based centers alongside EWI. And it's been great since then, of course, very busy. The way I describe the activities at the center, we have 4 goals. The first one was assigned to us by NASA to establish a public-private partnership. And a very good success story out of it, it's been the RAMPed project, funded to us through NASA, a very major award, close to 15 million, 14, 15 million, but not to all be spent at Auburn, but a lot of that funding, in fact, most of it goes to small manufacturers around the nation. And we support them with research on campus for them to align their product more to what's needed basically by NASA. The second goal we have is, of course, is to conduct research, both fundamental and applied, to advance the technology. In fact, I always say my goal for NCAME is the acronym, correct? The abbreviation of National Center for Additive Manufacturing Excellence, to be the transitioning mechanism for research to application. So basically, we do fundamental research, but we always put an eye on what's needed down the road, what's needed by industry. So you see a lot of applied research coming out of our group. The third one, through the partnership with ASTM and being their center of excellence, is to conduct research specifically to close standardizations gap. And finally, again, through a lot of collaboration with ASTM to design, promote, and offer a lot of education workforce development programs, such as training workshops, specialty workshops, as well as personal certifications that you see under ASTM portfolio. So based on this, you can imagine my days are filled, a lot of activities going on, but it's been really amazing. It's fun. Every day coming to work is definitely fun.
And in terms of machines, what sorts of hardware do you have at the facility? You mentioned powder bed, DED, some binder jet. Do you have
we don't have bonder. Yeah, we don't have
okay.
bonder jet yet, but we have a lot of collaboration around binder jet. Most of our equipment are powder bed fusion and DED. Currently, we have 12 metal AM machines, and hopefully a couple more to be purchased next year.
Fantastic. And so, I mean, when you were in industry, you had kind of a complaint that, hey, the folks we can't find the right talent. We have to train them internally to kind of get them up to speed. How has that shaped your own thinking, teaching as you train kind of the next generation of students, of workers related to manufacturing, additive manufacturing? Like, what are you seeing kind of on the ground there? Is there an interest in these careers? Are companies asking you every day to like, hey, like we need more people? Like what are you seeing kind of December 2022 as kind of the landscape in terms of teaching and workforce, and as it relates to additive?
One of the major challenges I see for additive industries in general is recruiting people or training the current workforce, correct? That's why, in fact, ASTM came up with this training program that tries to basically train the current workforce. They have interest in additive, or their organization is adopting the technology. We are involved in some of those activities, but specifically on campus, of course, we try to graduate students with deep understanding of additive process and potential applications. I believe the market is very hot for those graduates. Very often we have tours at our center from different government agencies or private industries, and what I need to make sure is they're not offering my students. So I need to tell my students, you need to graduate first. So they're ready to even offer them right there and encourage them to apply for their positions.
And is this at both the graduate level and the undergraduate level?
Well, I'm mostly involved with the graduate level because we are a research group, correct? We have right now the total number of graduate students, including mine and other faculty involved at the center, we are around 35. Mostly doctorate students, some master students, they're working at the center. When it comes to undergrad, that's interesting. I get email from certain companies and they say, oh, I'm working for, I'm not going to mention the company, for a certain company. And I took fatigue course, or I took machine design with you, or I work in your center over the summer and we have some additive projects. Will you be able to help us? So I see even undergraduate students now working in the industry, a lot of them are becoming involved with additive processes.
Yep. And as you've kind of built the center out and these collaborations between public and private, small companies, big companies, what are some lessons learned? I mean, I guess putting your shoes or putting yourself back in the shoes of industry, like for companies that want to engage with universities and work with them, like how should they think about those types of partnerships? Like what should they bring to the table? What should they be looking for? Kind of what should they be expecting when they want to engage with an organization like Auburn and the capabilities that you have? Like how do you frame those conversations so that it's a successful mission?
I think it goes back to the same applied research, correct? And you cannot blame academia, you cannot blame industry why they're not connected fully. In academia, they need to do research on something that's publishable. So it's more fundamental, correct? Typically TRL 1, 2, 3, 4, maybe 3, in fact, not even 4, because
Yeah.
the research is hard, it's publishable, correct? It's disruptive. And then on the other hand, industry often doesn't have the patience to go take the research from, let's say, TRL 3 or 4 and take it to 7, 8, 9, and then have the return of investment. So they want to get something almost ready, let's say TRL 7. So that leaves a gap between TRL, let's say 3, 4 to 6, 7, that's known as valley of death, correct? And I think the key for universities is to try to fill that gap. And by applied research, basically, you're making your research more ready for industry to adopt. And that helps to connect with industry better. And that's what we have been doing over the last few years.
Fantastic. And I mean, going back more to your kind of personal story, like you had kind of these experiences where you were in industry for a little bit, you were in academia, you were in industry. From a personal perspective, kind of what skill sets did you learn from both sides that made you successful, both in industry and the vice versa in academia? What sorts of things, as you've kind of look back on your career at this point, that like kind of stuck with you as big lessons learned?
The most important thing I learned in industry that you rarely find in academia is the sense of urgency. Specifically automotive industry, correct? You have models every year, and at some point, I remember Chrysler started mid-year models. So the life is very fast and you need to keep up with it. So you gain a lot of project management skills that is very challenging to learn in academia. Academia has a slow pace, correct? Is more on the education side. So I believe one of the reasons NCAME's been successful is trying to adopt that pace of industry to some extent. Still, we may not be as fast as industry, but we're trying not to be as slow as academia.
Sure. Yeah, and that's a common misconception, certainly. I mean, that in many cases it can be true. I mean, you're on a calendar that's fixed to the students, right? Like if there's not students to work on the projects, that can be a problem.
I give you a good example.
Yeah,
so you recruit a PhD student,
yeah,
doesn't know much about research publication, how to write a paper, how to perform a research, and you work hard 3, 4 years to train them. They become very a skillful individual toward the end of the PhD, and then they graduate and leave. You start over. So that slows you down. So you don't have access to professionals at all time. So but you're helping to train them. You're helping to train professionals, correct? Or train people to become uh, professional and have skill sets in their field. So that's a cycle that you go over. You go through it over and over during your career in academia. Often people come and go. They don't stay here long time, correct? And that's one challenge in academia. The second challenge in academia, it's very flat. You don't have a structure. So you have a principal investigator and everybody reports to the principal investigator. So it's like a small company that has one manager and everybody reports to the manager. The same manager has to do accounting, write budgets, write proposals, conduct the research or lead the research, work on the report, work on the publication, teach a course. It's challenging when you think about it like that. So because of these reasons, I mean, that's natural for academia not to have the pace of industry.
But at the same time, I imagine too, there's the good, I mean, really nice fits where like the ASTM piece, right? Where it's an industry-wide problem, or there's challenges industry-wide. Some of these industry partners are competitors, and there's the being at the university, it's a little bit of a neutral ground, so to speak, or can be, in terms of like, hey, we're going to do this, we're going to have a different perspective versus I'm just going to make this standard look the best for my company or my technology or whatever it may be.
Yes, definitely. We don't have any bias, correct?
Yeah.
So we're not competing with anyone. Often when there is a new contract, they ask me to write down if there is any IP I want to hold for us or something not to share. Typically, we don't. In fact, we like to share everything we do. That's why we publish.
Yeah.
And we're not here to make money, correct? We're definitely not for profit. Our products are students and research articles.
And for some of the students that may be listening to this, like when you are looking to bring people into your group or into the center, what are some of the skill sets that you're excited about? I mean, there's the technical piece, but are there other things that you're really interested in looking for and seeing as you recruit people to help expand the capabilities of the team?
I learned this from my advisor, so I need to cite him, but he would look into three things, and I'm looking into the same three things. First of all, to have the proper background, correct? If we are in the Department of Mechanical Engineering and we're doing a lot of materials research, I mean, it's less likely I can bring a biologist and expect to perform well. The second one is to the person to have passion about this major, about this topic. Without that, even you have the right background, it's difficult to wake up in the morning and go to work. The third one, which is very important and makes the third leg of this stool, is being hardworking individual. I believe hardworking can make up for a lot of things. So that's one thing I encourage my students and postdocs and research staff is to be hardworking individuals.
And how do you encourage that once they get onto into the group? Like, I mean, sometimes they have it naturally, but like, how do you continue to, as a leader of the group and leader of the teams, how do you continue to nurture that?
It's the environment, correct? They step into a relatively fast-moving environment. As I said, we try to be a little faster than the typical academia, and they have to adopt with the basically pace. The one thing I do, and maybe it's quite unique in academia, I let my student postdoc to directly interact with the sponsor. Typically in academia, the PI is the sole point of contact, but I allow my student to interact, and that motivates them to be responsive to the need of the sponsor, correct? So they get a better sense of urgency. They realize that the sponsor needs the data certain time. It's very different than if I tell them and try to be that basically middleman to basically convey the message.
Sure.
That's been working very well.
Yeah.
And also helps the student to learn some managerial skills, correct? Some communication skills. So we have a rule in our group is you have just a few hours to respond to the sponsor. If a sponsor is sending you an email, you need to respond the same day.
Mm-hmm. Yep. And that follows in industry too. I mean,
yeah,
great skills to learn.
Yeah. And in fact, a year ago, I was invited by Chrysler to give a seminar there. And I was sending an email to their tech flow who had invited me to say, hey, I need some information before the seminar. I sent the email at 2 p.m. At 2:50, he responded, and the first sentence was, sorry for my late response.
Yeah.
But that's something to learn from.
Absolutely. And you remember those sort of things too. So
yeah.
So kind of two more questions. So we're getting towards the end of the year here. What are you excited about for 2023? Whether it's kind of personal, whether it's professional, whether it's with the centers, what are some of the things on your radar that you're excited about for next year?
So maybe tough question. The life is so fast, often you forget to look ahead of you, correct? But what I see exciting in the industry is what I observe every year in conferences and gatherings. And one good example of it is ICAM that I've been co-chairing for the last 6 years, and every year is growing, just unbelievable. And it's not only the number of presentations and the attendees, it's the quality of the presentation and quality of the work going into it. And among all these 27 symposia that we have, there is one specific symposium that I have the most interest in. It is a student symposium. That's where students come every year and they present their work, and we have some awards. So every year we see over 100 students coming, and it's amazing when you see what's going on in different universities. Amazing work going on. And I've been always saying the future of this industry is very bright because of these students. So they're the one to join the workforce in a few years, and they can really lift a lot of weight.
Fantastic. So last question, again, more laid back, because I've been asking a lot of my guests recently, kind of what's one of your favorite books or books that has made an impact on you and helped shape some of your career and how you think about it. So we're putting a little 3 Degrees Discussions podcast book club together as people have some time, maybe over the holidays. So what would you add to that list?
I'm guessing you're not talking about textbooks.
It could be we haven't had a textbook yet, but we could certainly add it.
No, I mean, definitely there have been a lot of amazing textbooks that I've read, but one book that I can talk about, it's finance related book. Maybe two books: The Richest Man in Babylon and the Rich Dad Poor Dad, or Poor Dad Rich Dad. I forgot, Robert Kiyosaki. And these two books, not because I'm in finance or I spend a lot of times in personal finance, but the perspective they present and the way they look at the market, I think, is not limited to the financial basically market. It can be applied to different aspects of life in your professional career, personal life. So I really enjoyed reading these two books and the way they put things in perspective.
Perfect. We'll add them to the list. I've read one of them, so I haven't read the other one. I'm going to have to check that out. Rich Dad, Poor Dad. Years ago, yeah. I read that.
Yes, that's a good book, definitely. And The Richest Man in Babylon is a much older book, but you see that.
Perfect.
It's very interesting. Definitely read it.
Awesome. Well, Nima, thank you so much for joining the show. Look forward to seeing you around the conference circuit next year and maybe down in Auburn at one point.
Absolutely. Thanks again for the invitation.